Bienvenidos, Ushamdi, and welcome CTS-131 Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Cisco Networking Academy Routing and Switching Essentials V6 course, or the Networking 2 course at the college. And this afternoon's video tutorial and solution set is going to be on our Week 1 discussion topic, where we start the class out by talking about steps to configure a router. And you were given a list of requirements, and each student had to go through and put one command in order to complete the configuration. So let's go ahead and we're going to go right on to the packet tracer main window here, right? So go ahead and fire packet tracer up. If you're curious, on this box, I think I'm running packet tracer 7.1.1. So this is the latest and greatest version of packet tracer. It was released a little over a week ago. This is the version of packet tracer you should be looking to run. I know it's a little small there. It's 7.1.1.0138. And here's what we're going to do. We are literally going to go ahead and accomplish this from scratch. So we're going to come down here into the device area, and we're going to click on the 2901 router, and we're going to put a Cisco 2901 router out into our topology. Now, it's a little small right now, and that's okay, because what we're going to do is we'll be manipulating the text, and that will be a little larger. So here is our 2911 Cisco router. As you can see, as I mouse over it, it shows me some of the interfaces. Now, interestingly enough, one of the requirements is to configure an IP address and a description and to no-shut the serial 000 interface. However, when we look at this output here, what are we missing? Exactly, we're missing that serial interface. So by default in Packet Tracer, when we bring a Cisco router off of the production, the assembly line down here, and place it out into the packet tracer main map area, there is no serial interface. So let's go ahead and address that right now by assigning that interface, or by literally installing that interface. So when you click on the router, you'll notice that the first tab that opens up is the physical tab. And we get a nice picture here of what's going on in the router. And I actually have in my rack here at my house a number of these 2911 routers, and they look exactly as they're depicted right here. Now, we can see that we've got some different modules over here. We've got the HWIC 1GigE SFP, and so that's the high-speed WAN interface card is what HWIC stands for. Again, that's high-speed WAN interface card. It's 1 gigabit, and it's an SFP, right? And so that is a fiber connector. So we're not interested in the fiber connector. We've got a high-speed WAN interface card 2T, and this is going to be for the serial connections that we are interested in. So what we would do is we would click and hold down, and as you can see, it kind of animates right there. And we're going to get a dual port. That's what the 2T is for. We're getting a dual port serial card. Now, this isn't going to work right here, so watch what happens. I'm going to drop it here, and you can see it says can't add a module when the power is on. And this is actually a very true statement. When you're adding modules or line cards, you typically, if you can, you definitely want to shut power off. In fact, I typically remove the power plug from the router. So I cut all electrical feed from the router. I also have a static strap on, and then I install the component. So we see that we can't add the module when the power's on. So then that begs the question, how do we turn the power off? Well, the front panel on the 2911, which is also referred to, you'll hear this commonly referred to as an ISRG2, Generation 2. Integrated Services Router is what the ISR stands for. So this is an Integrated Services Router, Generation 2. And these are signified by that second digit, right? A 2900, a 3900, a 1900. That 9 indicates Generation 2, or G2. If it was a G1, which are the older routers, and now those are also end of support. As of about 2 years ago, those were no longer supported. And actually, it may have just been this past December, but they're definitely no longer supported. And those were signified by an 8 in that second slot. So 1800, 2800, 3800. Now, on the 2911s, you can barely see it right here, that little green light. So we're going to click on the bottom half of that. You can see the green light goes out. It's kind of tough to see here. It's small. But the green light goes out. And now let's test. If the green light's out, I should be able to bring over my serial card with 2 serial ports. It's an expansion card. And there, now we can drop it in. In fact, I've got some other cards. There's an HWIC 8A, right, that we could add in there. I've got a WIC cover. So I can actually cover slots that aren't being used. And then let's say if I wanted to put that HWIC 1 gig SFP in here, right? I could drop that in there. And so you've got these expansion slots into which you can place cards that give you additional interfaces with different functionality than the Gigabit Ethernet interfaces that the 2911 comes with. And it'll come with 3, Gig 0, Gig 1, and Gig 2. However, those are Ethernet connections only. So that's why we've got these expansion cards here. All right, so I'm going to go ahead, we're going to remove this guy, and I'll just put a cover, whoops, we'll put a cover right there. And now let's power it back on. So now that the power is back on, if we come to the CLI, we can see that it's booting. We're going to make a minor modification here. I'm going to come up to, where is it at? Options, Preferences, and we are going to change the font size here so that it is substantially bigger. We'll max it out at 20. That way it's a lot easier to see the command line. There we go, much better. So now I'm going to take up all of the space here. So this is exactly what you see on a real Cisco router, is that you're going to come to the system configuration dialog. Now, if I go to a real Cisco router, right, this is exactly what it looks like. Now, this is a Generation 1 or an ISR G1. This is an 1841 router. You can see that it's indicated here, right? And I'm running 15.3 code, which is a sort of recent code on this router. And so the same thing applies. We're going to say no because we're not interested in entering the initial configuration dialog. We're going to do things from scratch. And the same is true here. Although this packet tracer is going to be much quicker. So it says press return to get started. So we hit return a few times. Now, the activity gave you some requirements, and we got you off, or I should say the teaching staff got you off to a good start, right? We said that we're going to type the first command that would be required in the configuration, and that's the enable command. Now, when we're here at this prompt that says router greater than, remember the greater than sign represents user exec mode. And before I type enable, there's a limited number of things that we can do from user exec, right? And you'll notice that enable is one of those commands, and that allows us to increase our privilege level. So we can't say configure terminal here, right? Because I'm only in user exec mode. I need to elevate my privilege level in order to enable me to get into global config. So from privilege exec mode here with the greater than sign, I'm going to go ahead and say enable. And this was the command that was provided to sort of kick things off. Now, the hash sign, right, or the pound sign after router, that indicates privilege exec mode. Now I'm in an elevated mode of operation. And from this elevated mode of operation, I can now go into what we call global configuration mode. And it's from global configuration mode that we're going to be configuring probably 99% of what we do. So let me go ahead and say configure terminal, or you'll see this more commonly abbreviated to, hit tab there, to conf t. They both achieve the same result. They're both the same command. One is just abbreviated. So configure terminal, and that is going to put us into global configuration mode. So we went from user exec mode with little to no privileges to privilege exec mode with an elevated privilege level. And from that elevated privilege level, privilege exec, we can now enter configuration mode on the router. Now, the first thing that we are asked to do is to name the device Sydney. So how do we name the device? Well, we use the hostname command. And so this was Andrew entered this command in, so we would say hostname Sydney, right? And as you can see, the prompt actually changes immediately, and that's something to be aware of. With Cisco iOS, when we're making changes, these are real-time changes. So in other words, as soon as I change something, that change is going to take effect. We don't have to push the change or save the change. The change will take effect immediately. And so here we have hostname Sydney. So Andrew, excellent job. You got this correct. Now we go to the next requirement. It said disable DNS lookups. Now, why are we disabling DNS lookups? And this is something that you'll see probably about 99% of the time that people are going to do. The reason behind this command is that when you're on the command line of a Cisco router, and if I was in privilege exec mode, so I'll say enable, and this is a real Cisco router here, if I was to say configure and maybe forget, and actually let's pick a better thing here. If I were to do a typo and say CONFIUGRE and hit enter, and actually we don't even need to be in CONFIUGRE. So I mistype a legitimate command and I hit enter. And take a look at what happens. We go into this sort of loop here where it says configure, and it says translating configure. Well, this translating means it's trying to resolve this as a host name. That's what it thinks it is. And so take a look at the message here, bad IP address or host name. And it's because on this router, if I were to say show run include domain, and it's on this router, you can see that it's going to go through this if I don't have DNS lookups disabled. And sometimes this can become very tedious, where it can lock you up for a good 15 to 30 seconds before you get the prompt back. So that's why we're going to go ahead and say, and Emma got this right, we're going to go ahead and say no IP domain lookup. And that disables the DNS lookup. And again, the reason we want to disable the DNS lookup is if we mistype something on the command line from privilege exec mode, the iOS, right, is going to parse that command line and interpret it as if we're entering in the IP address or a host name that it is supposed to resolve. And so we say no IP domain lookup, and we no longer have the issue where it's sitting there trying to translate it and possibly locking us out of the session for 15 to 30 seconds. All right, the next requirement was encrypted privilege exec password of CCNA pass 1. And here's where I added in purple at the end of the activity a little additional information. So let's go ahead and knock this out. So encrypted privilege exec password. So I'm going to say enable, and what are my options from enable here? So I've got two options, password and secret. Now, we want to make sure that we're using a strong hash of the password. Now, if I was to use password, that's going to give me what's referred to as a type 7 password. In fact, let's go ahead and do that. I'm going to say enable password, and we'll say CCNA pass 1. Now, that would be incorrect, and I'll show you why. Now, when I say do show run, take a look. The password is in plain text right here in front of us, right? Now, what command might I enable, which Nick entered in, which we're going to be entering in here in a second, which command might I enable to encrypt all clear text passwords? And it would be service password encryption. So we're going to leave that incorrect so that we can see this. So I'm going to say service password encryption, and then I'll say do show run again. Now, as you can see here, this is what's referred to as a type 7 Cisco password, right? And while it is sort of obfuscated if a shoulder surfer, somebody was to be looking over your shoulder, and Cisco's been very clear about this, that these types of passwords are not meant to keep out the wiliest of hackers. They're meant to prevent the shoulder surfer. Maybe a junior administrator who's trying to get access that they don't already have, or it could be somebody, a bad actor at your company who's trying to get access to the routers or switches. And again, that's going to be a lot more difficult to remember than CCNA Pass 1. Now, this is still not what we want to do. What we want to do, and this is what I apologize, Nick Barnes, this is what Nick entered in. So Nick went ahead and put in enable secret CCNA PASS 1, and then he entered in the service password encryption command. It says the enable secret you have chosen is the same as your enable password. This is not recommended. It says re-enter the enable secret. So if I say do show run, you can see we now have both, right? But which do you think looks more robust, more secure? Yeah, clearly the type 5, and this is referred to as an MD, Message Digest 5, MD5. Now, how do we get rid of the other one? Well, let's say no enable password 7, and I can actually cut or copy and paste that. So we say do show run, and it's gone. Now, that is still, and this was the comment I added at the end, this is better, right? So good was the type 7, better is the type 5, but the best way to do this, and the Cisco recommended best practice would be, we'll get into global config here, to say enable, and we don't have this option in Packet Tracer. And even in the CCNA security materials, this isn't available, even though, or I should say the CCNA Packet Tracer activities, we can't do this, but this is the recommended best practice, is to use this algorithm type. And we want to use, and I'll show you, we've got some choices. You can see MD5 is there, and then we have script, which is a type 9, and we have SHA, which is a type 8. Well, script is the recommended best practice. It's considered the most secure. And then we say secret, and I'll say CCNA PASS 1. And let me show you why that is. So take a look. Take a look at that hash right there, right? Starting here at this $sign. This is exponentially more difficult to brute force attack and to try to crack than an MD5. So again, Nick, you are 100% correct, and this would be the correct answer, is simply enable secret, and then we don't have to put the 5 because we weren't using the hashed password. We were simply entering the plain text in, and now it's hashed for us. And then we said service password encryption. All right. Now, telnet access password of VTY PW123. So for that, we need to go to the virtual terminal lines, and that's what VTY stands for, virtual terminal lines. So I'm going to say line VTY, and now we pick the first line number, which we'll say is 0, and then the last line number, which is 15. On older devices, you may see examples where it says line VTY 0 to 4. And that's because those devices simply didn't have the raw sheer number of VTY lines available that the newer devices do. So typically 0 through 15 is what you're going to see. So we'll say line VTY 0 through 15. Now, before we make any changes, let's say do show run, and let's come down all the way to the bottom here, and let's see what we've got. So we've got line VTY 0, and that's where you see that 0 through 4, and then sort of you can consider this the expanded range, 5 to 15. And it just says login. That's all it says, right? Now, let's go take a look at at a real Cisco router, and we'll come all the way down here to the bottom. And you can see we have line VTY 0 through 4 login, right? And then transport input all. And what this transport input all means, and we'll come upon this semester, is I'm allowing any protocols to attempt to log in over the VTY lines. And what would those protocols be? Well, they could be Telnet, they could be SSH, it could be RSH, right? So I could allow anything to attempt to come in, and typically you don't want to do that. You want to allow only certain protocols that you're supporting. So for our purposes, we're interested in Telnet. So I'll say transport input, and if I do a question mark, you can see we've got all, none if we don't want to allow any logins, SSH or Telnet. Now, this technically in Packet Tracer wouldn't be required, but again, we're going to go ahead and hard code that in there because when we come back and look, you can see here at the end, now it says transport input Telnet. So we want to put, and I'm sorry, did I say, okay, yeah, Telnet access, that's right. So now we want to put a password here. So I could simply say password and then VTY PW 123. And this correct answer was entered in by Lauren. So I'm going to say VTY, what was the password? PW123, right? So we say do show run, we'll come down to the bottom. So I now have my password set to VTY123 and it says login, right? So when someone tries to telnet into this router, they're going to be prompted for login information, and they're going to be prompted for this password, right? All right, so that takes care of the VTY lines, and let me scroll back up here. Now we've got console access. So for that, and let me scoot back to the beginning, we're going to say line con 0, and we would simply say password, and the password's going to be con PW 123. So we've secured the router from a physical perspective, that console port, like somebody walking up with their laptop and a rollover cable to plug into the console port. And we've protected it from remote logins, from someone trying to telnet in. They're going to have to enter these passwords in. All right, so now we get down to the serial interface. And again, the interface that did not exist, do show IP interface brief, is how we see the interfaces on our router. This interface didn't exist until we powered the router down, inserted the card, and now you can see we have serial 000. And all of our ports here, the 3 previously mentioned Gigabit Ethernet ports, everything is administratively down, which means we are going to have to administratively bring those ports online. So the next command is to get in, and this is Dennis was able to get this correct, was to get into the interface, so interface serial 000, and from here we're going to apply the IP address. So we're going to say IP address, and the address is 209.165.200.1. Now, you'll notice I'm using a publicly routable IP address, and that's because as you work your way through the Cisco Networking Academy curriculum, typically the majority of the time, the overwhelming majority of the time, the serial interfaces will be used for WAN or wide area network connectivity. And that's kind of why we've got this 209 IP address here. And it is a /30, which is the CIDR notation you may remember from the Introduction to Networks course. And so the dotted decimal notation for the subnet mask for a /30 is 255.255.255.252. And so that is our IP address on this interface. We need to put a description on the interface. Let's add this in, and I'm simply going to say, and actually we've got it in quotes here, so we'll do the quotes, gateway to internet, right? Because again, that 209 address is a publicly routable address, and that is why we have it on that serial interface. Now we need to activate the interface. Well, to activate it, we say no shut or no shutdown. Again, it's simple to say shut, or simpler to say shut instead of typing out shutdown. And you can see that it says the interface changed to the state down. And the reason that the interface is in the down state is because it's just a router with the interface card. We're not actually connected to anything, right? And that's okay. And so those would have been the commands to configure the serial interface. And so Dennis got the interface serial 000. Nicole, well done on getting the description done. And then Dennis came back and he got the IP address sorted out. So now, and then Ryan was able to go into the interface and activate it by saying no shut, right? And very good job, Ryan, by putting shut. You didn't have to put shut down. Okay, so after the serial interface, we had the gigabit interface, and Alicia was able to get us into the gigabit interface. So let's go ahead and look at the requirements here. So let's get into interface Gigabit Ethernet 00. And so the first requirement is the IP address. Now this is going to be our inside, and this is commonly referred to as an RFC 1918 address. And so if you're interested in learning more about the RFC addresses, whoops, my pen kind of stopped working there, RFC 1918. If you were to Google this, right, Google RFC 1918, it'll take you to the IETF, Internet Engineering Task Force page, and it'll show you RFC 1918, which is all about the private, non-publicly routable IP addresses. In other words, these are the addresses that you would use inside your house, right? Behind your Comcast router, or behind your Verizon router, or your Cox or Time Warner internet router, right? And these would be the 10 dot addresses that you see often used, the 172.16s, and then the 192.168s, right? Now, these are your RFC 1918s because they are in the, now again, I don't have the ranges here. This is just sort of the starting point of where those ranges begin. But those are your RFC 1918 addresses that typically enterprises or companies use on the inside of their network. And then, as we'll see in this semester, as we get into chapters, I believe it's 8 and 9, we'll start to talk about network address translation. You'll see how those addresses get translated so that inside hosts that have these private addresses are able to communicate with devices on the public internet. And these IP addresses here, these are not routable. These ranges of addresses are not routable on the public internet. Your service provider is probably filtering any traffic it sees on the internet, right? Not coming from your router, but on the internet that have these as the address because they are not publicly routable. They're private IPs. All right. So we're going to get the IP address in here, and we're going to use a 172.16.1.254, and we're going to use a /24, which is that CIDR notation, that classless interdomain representation, right? And that is a /24, and that's a 24 bits are dedicated to the network portion of the address. So those 8 bits are the network portion. These 8 bits are part of the network, and so are those. And 8, 8, and 8 is 24. Whereas over here we had 30 bits dedicated to the network portion of the address, where we subnetted, right? We subnetted this 209, which is a class C. We subnetted it all the way down to a /30. And now we're taking a class B address and we're subnetting that to a /24. All right, and that's the IP address command for the gig00 interface. And then we also wanted to activate the interface, and this was done by, I don't think anybody got to this yet. No, this was still out there. So again, we already saw the no shut, so I'll throw that in there, and you can see it says the interface changed its state to up. So the final task that we had, whoops, I'm sorry, we've got the description. I forgot to put the description in here. So we'll say description connection to local internal LAN, right? So do show run. Let's look at our comments that we've got here, or descriptions that we have here. And descriptions are a great thing to add, because if someone comes after you, or maybe you forget why you configured the interface or what that interface is for, this is a very easy way to take a look and say, oh, that's right, it's the LAN interface, or oh yeah, this is the gateway to the internet. And that's why those descriptions get put in there. So we've got gig00 taken care of. Now we're going to go to the banner, and I'm looking to see if anybody got the banner in here, the MOTD. Yes, this was Brittany. Brittany got the MOTD. So how do we do the MOTD? Well, we say exit to get out of the interface configuration mode, and we say banner MOTD, and MOTD stands for message of the day. And we are putting in here, oh, actually, before I do that, if I do a question mark, this is important. So we're going to put a single character here, and you can see where it says C. Well, we don't want to use C, and this typically for learners will cause some confusion, because they see the letter C and they think, oh, okay, well then I'm supposed to put C and then put my message in. The problem is that C is the delimiting character. So if I was to put C in here and then say this, warning, and then it's unauthorized access. Well, it says unauthorized access only. And I think what it wants to say is warning, authorized access only, an exclamation mark. Now, here's the problem with what we just did. So I have and I kept it all on one line. So I have the C here, right? As soon as we get to that C right there, it's going to think that those are the delimiting characters. So we put the C here, and we're telling the command line, we're telling iOS, when you parse this, when you encounter C, this is the start of my banner, my message of the day. And the next time you encounter C, right there, that is the end of the banner message of the day. And then we miss all of this. Does not show up. And so that's why that tends to cause some confusion, is learners see this and they say, oh, I'm going to put the letter C in there. And then they type everything out, and let's see what happens here. Actually, this is probably going to kick back an error. Let's see what we get. Okay, so you can see we have banner MOTD. We didn't get an error, and let's see what happens when I log out. And I'm on the console, so press return to get logged in. So you can see it says warning, authorized A. Well, what happened? Yeah, so what was the character after the A supposed to be? Yes, the delimiting character. And that's why we don't get anything after that, right? So be wary of that. Here's what I typically do. And let's get it, so we're in user exec mode. Let's use the enable command to get into privilege exec. And then let's put our password in, which was CCNA PASS1. CCNA PASS1, and okay, there we go. Thought I may have forgotten it there. All right, so now we're back into privilege exec mode. We'll get into global config. And I usually use the %, right? And I also usually hit enter a couple times, because see, now we get this message here. It says, now I can kind of free flow enter the text in. Well, this gives me an opportunity to say, warning, whoops, warning, exclamation mark, and we'll put authorized, because I'm pretty sure authorized access only, that is what it wants it to say. Now you'll notice when I hit enter a few times, nothing is happening. Why is nothing happening? Exactly, because I now need to end with that % character. So we throw the % character in here. There's no chance that with just plain text that I would have the % in there, which is typically why I use it, and that guarantees we don't run into this kind of a scenario where we're missing characters. So that is the banner of the day. Now save the running config. So there's a couple ways we can do this. I'm going to show you the conventional way, and we're going to go ahead and say copy running config to the startup configuration, because right now we're editing the running config. So if I was to reload the router right now, we would lose everything we just did, right? But when I back it up like this, now we have a copy, or I should say, now we have stored it on the non-volatile storage space, the NVRAM of the router, which means when the router goes to boot up, that is the configuration file it's going to load. All right, so we've saved our configuration. Now there's another easier way to save things. You can say write memory, right? And that is equivalent, it is synonymous with copy running config, startup config. And in fact, you don't even have to spell write memory out. You can say write mem and hit enter. And that does exactly what copy running config, startup config does. So we've saved the configuration. All right, so here's what we're going to do. We're going to review what we just did in one fell swoop on a real Cisco router. So I'm at the user exec prop. We're going to say enable to get into privilege exec. And what did I, CCNA PASS1, is that what I used? I can't, ABC 123, I can't remember. Okay, I've got other routers here. We'll come over to router 4. I can't remember the password I put in there, I'm sorry. All right, so we'll come over to router 4, as you can see, right? Do we want to enter the initial configuration dialog? The answer to that is a resounding no. And as you can see, it takes these routers just a little longer to get us to where we need to be. All right, so here I am in privilege exec. I'm going to say enable, in user exec with the greater than sign. I'm going to say enable to get into privilege exec, and we're going to set the host name. So I go configure terminal to get into global config mode. I say host name Sydney. The next thing we want to do is say no IP domain-lookup. And then we're going to encrypted privilege exec password. So enable secret, and it was CCNA PASS1. And then I'm going to set the console access password, so line con 0. And we're going to say password CONPW123. And then the telnet access password, line VTY 0 to 15. Password is going to be VTY PW123. And again, you may want to add in here transport input telnet, right? And encrypt all clear text passwords. So in order to do that, we say service, oh, I'm sorry, I'm in the line. So I should say exit there. So service password encryption. And then we are going to set the IP address. I happen to have a serial interface on here. I'm going to put that :0 at the end. Pay no attention to that. That's just because of the type of serial interface I have. But I do have a serial 0, do show IP interface brief, or do I? I do not. Okay, so this should have had a serial interface on it. And if I pull it in, it's going to configure it. I have a configuration that I've got stored here in order to bring that online. So let's do, so we'll skip well, actually, instead of skipping it, I'll just do this. We'll come over here and we'll get into global config interface serial 000:0, and I'll just change the IP on this one. So here's our serial 000 command. We're going to say IP address 209.165.200.1. This is a /30. and then we're going to say no shut, and we're going to put our description on here, which is gateway to the internet, and then we're going to activate it. I'm sorry, we said no shut already and activated it. Okay, now we'll move back to router 4 here and continue on. And actually, you know what? We'll stay on 13. It's got the gig interfaces. So we'll say interface Gigabit Ethernet 00, and we're going to put the IP address on here. So IP address 172.16.1.254, and this is a /24 or a 255.255.255.0. I'll say no shut to activate it, and then I'll put our description on here of connection to local internal LAN, right? And we activated it with the no shut, and now I need a banner, so I'll say exit, and then banner MOTD. I'll use the % sign, put a little extra space in there, and I'll say warning, authorized, access only. All right, and then we'll put our % sign by itself, hit enter, type end, and then we can say write mem, which is the same thing as saying copy running config to startup config. And that's it. All right, well, fantastic job. I'm actually going to put this in a text file for you as well so that you can see the commands that we ran. And that is going to wrap up this tutorial and solution set on the week 1 discussion item, which was steps to configuring a router. All right, I will talk with you guys soon, and thanks for watching.